Okay guys, so these are the skills that you need to be able to understand section 4.3. So obviously you need to be able to distribute, right? 3x times x squared, that's 3x to the third. 3x times 2x, that is 6x squared. 3x times negative 8, that's negative 24 with an x. Everybody should know that from Algebra 1. Now when you have a binomial times a binomial, that's pretty easy to do. It's really just distributive property, but instead of one thing that you're distributing, you actually have two things that you need to distribute. So I'm going to begin with the x, right? I'm going to say x times x, that's x squared. X times negative 4, that's negative 4x. So it's kind of like if I ignored this plus 3, right? And now I'm going to move the block over and ignore the x and simply distribute this plus 3. Distribute it 3 times x, positive 3x. 3 times negative 4 is negative 12. Combine the middle terms, you end up with a negative 1x. Bring down the x squared in front, bring down the minus 12 at the end. And that's your simplified quadratic trinomial right there. Why do I say quadratic? Remember, quadratic is anything that has a power of 2. There's 3 terms. It is a trinomial. Okay, anyway, let's do this last one. Let's distribute 2x times 3x, that's 6, because 2 times 3 is 6. X times x is x squared. 2x times negative 4, that's a negative 8 with an x, so that's negative 8x. And distribute the 1. 1 times 3x is a positive 3x. 1 times negative 4 is a negative 4. Combine the middle terms, so you have a negative 8 with a positive 3, that's a negative 5. And of course, we're talking about x's. Bring down the 6x squared, bring down the minus 4, and there's your answer. That's distributive property, and if you don't know how to do that, there's no way you're going to pass this next lesson, all right? Now, we also should have known how to factor. We should have learned how to factor, bless you, back in Algebra 1. So what is factoring in your own words? What would you guys say factoring is? Everybody write this down. What is factoring? It's reverse distributive property. So it's like kind of having the answer and going backwards to the question, right? So if I told you, for example, if I told you factor x squared minus 1x minus 12, where did I get this from? I got it from this answer up here, all right? If I told you factor, what I'm really asking you is, can you do a reverse distributive property to get back to the question, right? So you put an x right there and an x right there. That's like saying factor that, then your answer would be the question that we started with, the x plus 3 times x minus 4. And of course, we're going to have a strategy for factoring. We're going to review factoring tomorrow. You don't have to remember that right now. Anyway, let's move on to the pre-notes to tomorrow's notes. This is what we need to know right now, guys. Circle this. Solutions, x-intercepts, roots. All of those, what do they mean? Answers. So if I say find the solutions, of course, find the answers. If I say find the x-intercepts, that also means find the answers. If I say find the roots, that also means find the answers, right? It's all the same thing. That's exactly what I say on these notes. They all mean the same thing when it comes to quadratic equations. They are all answers. Okay, so we have some simple questions right here. What are the solutions to this simple quadratic equation x squared equals 9? A solution is something that will make it a true statement. So what number squared will give you 9? 3. Okay, so what's the answer? X equals 3. But there's another answer also that'll work. What's the other answer? Negative 3 will also work, right? So if you're thinking, oh, 3 squared gives me 9, but if I plug in a negative 3, in parentheses and square it, it'll also give me 9. So we actually have 2 answers right there. Okay, 2 answers. So they say, what are the solutions? It's x equals 3 and x equals negative 3. Now, they could have asked the question like this. What are the roots? It's the same exact thing, right? But why the heck would they call it roots? So let me explain a different way of approaching this. Instead of just thinking what number will work right here, that'll give me 9 as an answer. How do we solve equations up until now, or how have we always solved the equations? You want to get x by itself. And how do you get rid of something? You do the opposite, right? So I have an x squared. If I just want x, if I don't want this little square, I'd have to do the opposite of a square. And what is the opposite of a square? A square root. So that's where the word roots come from, right? Because I could actually square root and square root. So the square root of x squared is x, and there is a rule on equations. Whenever you apply a square root while solving an equation, you have to put a plus or minus right in front of your answer. So a plus or minus 3. So you see how it's really asking the same thing. Find the solutions. Oh, 3 and negative 3. What are the roots? Okay, well, yeah, you're going to solve it by applying the root, square root on both sides, and you end up with the plus minus 3, which is the same thing as positive 3, negative 3. How about this? Another way of asking it, what are the x-intercepts? So what are the x-intercepts? How do we find the x-intercept? You set y equal to 0, right? You guys remember that? Okay, so if we were to set y equal to 0, I would actually have, let me write, set y equal to 0. I would actually have 0 equals x squared minus 9. And usually I don't like the equals on this side. Let me put the equals on that side. So let me rewrite this thing and say x squared minus 9 equals 0. Okay, so that's an equation that I could solve, right? And how do I solve it?
Plus 9.
Add 9 to both sides, so plus 9. I will have x squared equals 9, and again, I get the same answers. What are the same answers? X equals positive 3 and negative 3. So you can put a plus minus, or you can actually write it out. But why did I do these 3 simple examples? Just to show you that it's all the same thing. The words mean the same thing. What words? If I tell you find the solutions, oh, those are the answers. If I say find the roots, well, yeah, you apply a square root. That's why they call it roots also, and you get the same answer. Find the x-intercepts. What do? You set y equal to 0, and you solve it, okay? Which ends up giving you the same equation with the same answers. Important fact, you can solve any quadratic equation with the graphing calculator. The answers will be where the parabola crosses the x-axis. Okay, since we know that x-intercepts are the same thing as answers, whenever they tell you to solve, you could just graph it with the graphing calculator, and wherever they cross the x-axis, that's your answer. So this parabola right here, it came from some type of quadratic equation, right? And if I told you solve that quadratic equation, what would your answers be? Where does it cross the x-axis? It doesn't cross. So this would be an example of a no solution problem. No solution. Because it doesn't cross the x-axis. Okay, over here, whatever this quadratic equation is, what's the answers? Just the answer 2. So right here, if I were to solve it, it would give me x equals 2. Because my x-intercept is 2, my answer is x equals 2. And over here, what would my answers be? 1 and 3. And it's that simple, guys, right? You could use a graphing calculator to solve any quadratic equation, and wherever it crosses your x-axis, that will be your answer, or answers. So you could get x equals 1 and 3 in this case. So down here it says, oh, there's 2 x-intercepts, there's 1 x-intercept, there's no x-intercept. Remember, x-intercepts means answers, right? That's what it says up here. X-intercepts means answers. So if I tell you, find the answers, and you graph it and it doesn't cross, then you would say no solution. If it crosses at one point, then it only has one answer. If it actually crosses at 2 locations, then these 2 locations are your answers. So what if I would have graphed this guy right here? Y equals x squared minus 9. If I would have graphed it, where would the parabola cross the x-axis? At 3 and also at negative 3. Okay, so it's all related. Okay, graphing, solving, it's all related. And you could solve by graphing and looking at your x-intercept values. I would like us to turn to page 233 and do questions 1 through 3 and 14 through 19. Now, you don't have to copy them down. I just want you to look at them and state the answers just by looking at them. So, ladies and gentlemen, we have the picture of the page right here, page 233. So, check this out. It says, use a related graph of each equation to determine its solutions. So, imagine that somebody just gave you this quadratic equation, x squared plus 2x plus 3 equals 0, and you're trying to find that actual x value that'll make it equal 0, right? You're trying to find the answers. You're trying to find the solutions. Now, because of what we just learned, that solutions, answers, roots, x-intercepts all mean the same thing. If they ask you to find those answers, you could just look at the graph, and what would you say to this first one? No solution. Boom. So that's the answer to number 1, right? I guess you don't even have to copy it down since we're looking at it right here together. I'm sorry about grabbing the books. You could just pay attention right here. Number 2, what would the solutions here be?
5 and -2.
Yeah, 5 and -2. Now, this is the crazy part, right? These answers, these x-intercepts are answers, which means if I take -2 and plug it in right here and right there, when I do the math, it will check out and give me 0. If I plug in a 5 right there and plug in a 5 right there and do the math, it'll check out and give me 0. Don't believe me? Check it out. What's 5 squared? 25. What's 3 times 5? -15. So I really have 25 minus 15 minus 10. 25 minus 15 is 10. 10 minus 10 really is 0. It checks out, right? So this is great news, guys, because no matter what type of crazy quadratic equation that they ask you to solve in the future, if you have a graphing calculator, you can simply graph it and then look at where it crosses the x-axis and you'll be good. So what's the answer to this guy? Yeah, the A value is negative. It's opening down. It has a pattern 1, 1, 2, 4, 3, 9. Okay, but the answer is right here, -1, 2, 3, 4. -4 is your answer because it's your x-intercept. Now, if you don't believe me, you could plug in -4 right here and -4 right here and do the math, and it will check out to be 0. Now, keep in mind, guys, sometimes you have one answer, x equals -4. Sometimes you have two answers, -2 and +5. Sometimes you have no answers. It all depends if it actually touches the x-axis, crosses the x-axis at 2 locations, or it doesn't cross at all. All right? Looking at the other ones, what's the answer number 14 right there? 0 and -4, right? So 0 and -4. So the answers here, x equals 0, x equals -4, just by looking at the graph. Now, we're not going to always have the graph, and we're not always going to have graphing calculators. So we will have to learn how to solve these by hand with algebra instead of visually. How about number 15? What's the answer to 15?
Nothing.
No solution. How about 16?
2.
X equals what?
2.
2? Yeah, see how amazingly easy this is? What's the answer number 17?
-2.
-2. Like, could you imagine if I gave you this original quadratic equation with the decimal? You guys would freak out. But if you graph it, it ends up being a nice, beautiful answer. Just that, -2. 18?
Nothing.
No solution. 19?
-3 and
3 and 4. Okay, so -3, -3, +4. X equals -3, x equals +4. So do you guys see why on past worksheets I tell you to state the x-intercept?
Yes.
And if it wasn't at a nice point, I told you to give me a decimal approximation, because we are building up to this to be able to get the answers from the x-intercepts, because the x-intercepts really are answers. Ladies and gentlemen, I'm done. Finish up whatever homework you haven't finished.